session. So I think as we continue to evolve the agenda and the topics for the reliability and security workshop, we'll continue to see breakout sessions like this. So I hope this will meet your expectations. I know I'm looking forward to this next session. And so I hope you all had a great time last night on the dine-arounds, dinner, and we'll go ahead and get started. We've got a large load and the potential impacts to small and medium entities for this next session. We have Sean Wagner from NV Energy, who is on the line, and Bill Fletcher from WEC, as well as Enoch Davies. So please join us in this session, and I'll let these guys get started. Thanks.
Thank you, Kim. Let's see here. Mike sounding okay? Thank you, Kim. Good morning, everyone. As Kim said, we're doing some new things here with our workshops and being technically focused on this session and trying to have some connections with industry who have experience. So for the large load considerations here, and let's see here. Oh, this was working. Oh, okay, very good. So Sean, the way this evolved was, I guess before I do that, couple of remarks that as we go through the presentation, you heard some presentations yesterday on large loads. Three things that can kind of come to mind. One is Steve Massey mentioned yesterday, Jim Robbs. Yeah. Okay, thank you. All right. I mentioned in Jim Robbs' remark about, yeah, okay. Oh, okay, so that one's not there. All right, great. Okay, thanks. We didn't have a light there, so. There was Jim Robbs' remark about, Steve Massey mentioned about trying to avoid admiring the problem. So that's something I try to keep mindful of every day that we work here. And the other is that something that John Pispisa from SoCal Edison mentioned in a technical workshop, I think online about a year and a half ago, basically saying, that when the grid's talking, we should be listening. And I think we're trying to do that. And the other thought that comes to mind with large loads and all, as you'll see, all of the things that are evolving, the task forces, the market interface proposals that Southwest Power Pool is going to talk about on the other side of the room, is that the grid is evolving at the speed of thought. And with regard to large loads, it's something that I'm reminded of, especially when we talk about data centers. It was proposed at the CERN Physics Laboratory in the mid-90s, was a proposal by a guy named Tim Berners-Lee about unifying information systems with something called the hypertext transfer protocol. And his boss responded to this back of the envelope sketches, vague but exciting. You can look that up. So in a way, as we're evolving with large loads, this is not the large loads of arc furnaces of days behind. Those are still there. But these loads could actually be virtual. These loads vary with the speed of thought, and that it is at the same time vague and exciting. So with that, we'll go ahead and get started. And I want to make sure Sean is here, and you can hear us okay, Sean?
Yes, you're good. Can you hear me good? Perfect.
Okay, so still trying to advance the slides here. And that's not working. Try one more time. Yay. Okay, and we also have Sean there. So a little bit of background information. And let's see, my monitor up here is not advancing. So an increasing number of large commercial and industrial loads are rapidly connecting to the bulk power system. There are data centers, including crypto, artificial intelligence. That's a quote that's out of the NERC Large Load Task Force document. And within this presentation, you've been an audience for some of the ones I've done over 17 years. I try to the toolkit approach so that after the presentation, there's some useful resources. So we're going to attempt to do that. So we'll have Sean will be here from NV Energy. They have experience connecting and serving the loads. We'll be discussing challenges and lessons learned, or they will be, he will be. There will be a lot of focus on operations and planning and information of interest for small to medium entities. And then what are some reliability challenges and opportunities? And we'll have your questions at the end. So for preparations of this, we asked Gemini at the speed of thought, how much power is consumed per day in the US in AI searches? And with any AI search, it's always good to vet. What we got back, and on the right-hand side are the sources that you vet when you ask Gemini a question. These are a little bit difficult to read, but basically it's talking about, when we said vague but exciting, the energy use per AI queries, depending on the model, that's the learning model. Tech companies are not required to release emissions or any energy use data, which is an ongoing challenge as for those of you that I spoke to seeking your interest in presenting. There are some challenges with that because they do keep a lot of what they do proprietary, and yet you have to serve the load. AI is fast moving, energy strain concentrated in certain regions with high data center density, talking about the Eastern Interconnection. Rapidly growing, doubling demand. Consumption to increase 130% by 2030. These are estimates. But it's interesting to see what AI is telling about itself and about what's happening. In 2028, data centers could be equivalent to the energy consumption as much as 22% of all U.S. households. ENIC has some other data that that we're looking at for planning. Representative activity timeline. We had presentations yesterday, and this slide was being updated as early as this week because I needed to pick up the load modeling working group workshop, which is online and free. All these are URLs related and resources back to large loads for you to looking at, starting with the Eastern Interconnection incident of 1,500 megawatts that was behind the meter. So then NERC formed the Large Load Task Force, which is ongoing. Long-term reliability assessment for technical conference and so forth. So there's a lot of literature there for your research. A slide out of the large list task framework is that there is a white paper Q2. There's another white paper Katie Rogers and ENIC referred to yesterday. A reliability guideline due out Q1 2026, and the standards authorization request. And on the previous slide, one of the things I didn't mention was the NERC alert and data request that goes out that's due January 28th. So demand drivers from the NERC long-term reliability assessment in the Western Interconnect. We can see that data centers are being identified as well as electrification and transportation. Today's discussion will be mostly about the data centers and the data center experience that NV Energy has and has been serving for several years. One takeaway I wanted to share from the EPRI 2024 report was that they highlighted 3 essential strategies to support rapid data center expansions: efficiency improvements and increased flexibility. We might get into that efficiency discussion. Years ago, I was an internet service provider, and I do remember a paper that was produced about potential electric efficiencies with data centers, but this was back at a time when we didn't have the dynamic load growth and data center growth that we're experiencing now. But close coordination between data center developers and electric companies. This number 2 item was especially poignant 2 or 3 large load task forces ago, there was a presentation by Evan Pierce, who's very entrenched in data center provisioning and loads and worked here at WEC. But I remember his remarks about close coordination between developers and electric companies ready data center power needs. Those power needs, as we'll see, if it's driven by AI, can be dynamic, as in data centers don't have to be point source. They could be virtual, another form of virtualization, and learning networks can be distributed over multiple data centers. So morning session wouldn't be the same without a Slido poll. So that is our Slido poll. How is a large load going to be defined or going to be defined? So if you want to go ahead and do that, let's see what the audience says. And you can so far it depends. We've got 3 responses. So now there is no right answer to this because it's still being just, analyzed and defined. But so now with that, what do you think? And let's see, markets will define is that down around 4%. In the large load session, Southwest Power Pool will have some pretty interesting material to show about that may provide some different insights, at least from the standpoint of how their stakeholders in the market is providing information about large loads. So we got NERC will define and it depends. Okay, really interesting. I didn't have a prediction how this would go. Did you, Enoch?
I was sure hoping they'd tell us like 75 megawatts or something.
Okay. We'll go ahead and move on here. And with that, Sean may have something to say besides it depends. Sean Wagner is a director of transmission projects at NV Energy. Sean and I almost by accident came up, we were working on some other matters, and it came up that he had an interest in large loads. They have experience in large loads. Sean's also an adjunct professor at an institution here in San Diego he can talk more about, but really appreciate his willingness to present. He came forward and offered as a panelist. Not easy to do under that circumstance, was all prepared to be here and then had a constraint, was not able to travel. So thanks to our wizard work with Maylee and the committee and Megan and Serena, we're able to get Sean here participating in real time because he really has the discussion points of lesson learned. They're active practitioners in serving data centers and growing. And with that, Sean, I will run the slides and welcome.
Absolutely. So thank you for having me. I don't have any catchy jokes, but about attachments like Joshua wrote, but I will say, I kind of want to set the stage a little bit. So NV Energy, the primary provider for the state of Nevada, if you weren't aware, we do have some facilities in California, but that's pretty much our footprint, about 2 million metered accounts, all things said and done, and a very large geographic footprint. So having said that, we had our Slido there in terms of, what's a large load? I think it's important to understand from our perspective what that looks like. And so I was reminded this month that it is the 40th anniversary, this will make you feel old, of the Back to the Future movie. And so if anyone remembers, we needed 1.21 gigawatts of electricity to go back in time. It just took a little bit of plutonium to make that happen in the movie, but that certainly isn't the case here. So to kind of put that into perspective, and I'm sure somebody will fact check me with ChatGPT or Gemini, 1,000 megawatts is a gigawatt. We're probably well familiar with that. But if we quantify that, that can be 1 million homes. So when you talk about data centers coming in asking for 100 megawatts, 300 megawatts, 500 megawatts, 1,000 megawatts, we are talking about millions of homes if we look at it that way. Now, of course, it's not a complete apples to apples comparison, admittedly. All right, Bill, go ahead and advance me. So from our perspective, what is a large, complex load? What do these data centers look like? And so it's really important that we're here sharing that. We're sharing our experience. One of the big differences that we've seen is that with these new large loads, we are not just adding homes. We're not just adding hotels, casinos, as some of you are probably aware in the state of Nevada. We are adding a continuous demand, a 100% uptime with these data centers. That is fundamentally changing the load profile. And so a lot has to go into the planning. We really have to think creatively in terms of how are we going to serve these folks? How are we going to meet this 365-day demand? Another struggle that we see is, and I'm sure some folks in the room are familiar with this, customers want what they want, right? They want power when their construction is complete, and rightfully so. I mean, I don't blame them. But unfortunately, things like the Back to the Future movie have skewed what that actually looks like. We don't just flip a switch and get a gigawatt of power. And so material, logistics challenges, you name it, they were just not in alignment with those needs. And so that's a struggle. The other part that customers don't always understand, and really, outsiders, the public doesn't always understand, that it's not easy to build high voltage transmission. A lot goes into building those transmission lines. And candidly, you're not going to just go build a transmission line in 3 to 5 years. It just doesn't work that way. And the higher the voltage gets, again, I'm probably not telling the folks in the room anything they don't know, the complexity gets more challenging. And you start looking at timeframes, and we get up to the 10-year mark for some of these projects. Well, that's not going to work for a data center. That transformation is here and it's now. Go ahead, Bill. All right, so herein lies the struggle. Our mission, by definition here, is to be the best and the easiest utility to work with in the state of Nevada. Now, candidly, as the primary electric provider, right, that's a little skewed, because who are you really benchmarking against? But we certainly want to be the easiest to work with. And when we look at some of these data centers, that's a challenge. How can we meet our core mission here when we know that the timeframes really aren't going to line up? One of the things that is also interesting about NB Energy is, if folks aren't aware of this, is we're very geographically diverse. And what I mean by that is we have a northern part of the company and a southern part of the company. And in talking with Bill, I think it's important to understand that we can relate to the small to medium entities. Point being, the Las Vegas area is very much so a large utility. The majority of the customers are down there. If you haven't been to Vegas, they tear down hotels to build taller hotels. So it is definitely a new system that is a very loop system. It is a system that is easily scalable. Unfortunately, the northern part of the territory is not that way. So for small to medium entities, you can probably relate to this. We have facilities that are over 100 years old, a lot of radial facilities. We were challenged with an economy and a market that didn't really grow for about 20 years, folks. It was very stagnant. So not a lot of investment, not something that was really the focus of the company. Good, bad, or indifferent. So when you look at that sheer geographic footprint, trying to build transmission across the state, dealing with a very diverse geographic footprint. Fun fact, state of Nevada has more mountain ranges than any other state in the continental US. It's not very easy to build transmission lines over mountains. And then throw in the fact that 80 to 85% of the state is federal land. Sorry, Bill. Enoch, it's not always the easiest to work with regulators when you're trying to build transmission lines. Again, good, bad, or indifferent, BLM, U.S. Forest Service, BIA, you name it. There are certainly some challenges there in meeting those timeframes. So to move on to our next slide, we really went through a SWOT analysis to kind of break down what we've done, some of the things that have gone well, some of the challenges, the threats that we see. So for my small to medium folks, I cannot stress enough how important it is to have proactive planning. One of the things that we've seen, 2 decades of very stagnant growth compared to today, is that our IRP, our integrated resource plan, has seen skyrocketing demand. We went from a max of 2.5 gigawatts to 4.3 gigawatts in our IRP in the last 5 years. So we virtually doubled it. We have contracts that, and for some of you, you probably noticed, our contracts are actually more than the IRP. And some of that is because the load profiles are outside of that 3-year window with our IRP. But we've also seen 15 gigawatts of new load requests. And folks, that's just in the northern area of the state. The southern area of the state is closer to 10 gigawatts. So again, to put that into perspective, state of California on a regular basis is right around 30 to 33 gigawatts. Again, I'm sure someone will fact check me on that, but let's just take the numbers as they are. We are looking at growth that is half of the state of California. That is just insane when you think about it in a very small footprint in northern Nevada. Now, the good news, a strength though, is that there's a lot of interest in the state of Nevada. We are certainly excited for what the future has to hold. We have about 80 gigawatts of proposed generators in the queue. Now, the challenge there, though, is that that's not necessarily company-driven projects. It's developers. It's the gamut there. So we don't control those projects for the most part, but the interest is there. The other thing that is very unique about Nevada, particularly NV Energy, is we're also the balancing authority and the system operator, which is a good thing, and it does create some additional complexity there. The other thing that we've also seen that has been a strength, and we've been very happy that our PUCN has been receptive to this. They've been willing to depreciate assets beyond 70 years when we've proposed it to them. So that is a positive. That is definitely something where we look at the sheer cost of some of these improvements. There's just no way to really recover and put that burden on our ratepayers in a short amount of time. So that's been a very positive thing that we've seen. Our commissions have been working with us, or our commission has been working with us. Go ahead, Bill. All right. So the challenge, though, is we are only as good as the information we get. So one of the things that I would caution, small to medium entities is make sure you're listening to customers. Make sure you're listening. But it really has to be a candid conversation. So one thing we've seen is that all things considered, the loads aren't showing up maybe as quickly as our forecasts predicted. Now, with data centers, as Bill mentioned, that can change overnight. So we are very cautious in saying that. It certainly is a weakness. It certainly is something that we struggle with our commissions to go in and justify projects if the load isn't there. But in the same sense, it can turn on a dime. So please listen to your customers, work with them, have candid conversations. And likewise, with those candid conversations, have the conversations about mismatched timelines. I don't think we are alone in that transformers are taking 3 to 4 years, especially for the bulk electrics type of equipment. Breakers, control enclosures, switch gear, you name it. The timelines certainly are not in alignment with data center customers. And also, we have aging infrastructure. I mentioned, we have some facilities over 100 years old. Average age of substations in the U.S. is over 50 years. Folks, they don't last forever. They certainly, should be in your 10-year plan for some kind of retrofit or replacement as they creep over that 50-year mark. And so that's a challenge. You can't possibly rebuild the whole system. And then that cost and ratepayer risk, how can we expect our customers to foot the bill for all of these specialized improvements, all this specialized infrastructure? So you really need to look at those cost sharing agreements, advances subject to potential refund. I would say that there's not a one size fits all. It is something that a lot of other utilities struggle with. And I wouldn't say that we're perfect with this either. We struggle with it as well. What should that cost sharing look like? What should the burden be on our ratepayer? Go ahead, Bill. Okay, so, I don't want it to sound like doom and gloom, but there are certainly some opportunities here. We've had some real success with clean transition tariffs. So again, being creative. We've had some success with demand response and DER integration. We've seen instances where we've been able to reduce about a gigawatt of load when needed. Now, admittedly, it's for a shorter duration. It's not necessarily a solution for data centers, but it should be part of the conversation. And then the other opportunity is the sheer growth. You build these tech hubs. Admittedly, they're not always manned facilities or heavily manned, but it's going to bring economic development any way you slice it. And then Bill will probably talk about this more, but we talked in detail about this. What does the next generation conservation look like? One of the things that our data centers have really struggled with our local governmental agencies is, hey, where are you going to get the water for cooling here? What kind of impact is this going to have on the community beyond your power demand? So we really are very aware that there's potential for more advanced or sustainable cooling solutions out there. So we're excited for that. What that ultimately looks like, we don't know. All right, next slide, please, Bill. Perfect. So this is definitely one of those things that it does keep us up at night. It's something that we certainly are aware of. So what does unplanned load growth look like? So these virtual power plants that Bill talked about, what are the impacts on grid reliability, blackouts? What's the competition and bias look like? So with things like co-location, right? It's definitely a hot topic. It's something that many data centers are talking about. But ultimately, what does that look like if these data centers come online and they end up not using power? What does that look like? What does that long-term recovery look like? It's a very valid threat to the industry. The other piece of it that a lot of people don't think about, though, is that because of the uptime with these data centers, they still may require redundant power. So just like a hospital, right? If they lose their power on site, they may want to use the grid. Well, you got to think, you're not just going to get a gigawatt of power instantaneously to support these customers. So what does that cost recovery look like if in fact they're using their own power? And then regulatory scrutiny, we have seen some of this, rightfully so. The load profiles haven't always been the best from the customer. So I would say that you have to be conservative in terms of how you invest in your network upgrades, but in the same sense, you don't want to be behind either when they are ready to flip the switch. So it's a delicate balance. And then certainly the environmental concerns here. This is the one that I don't know if a lot of people are talking about. For the state of Nevada, we have an RPS renewable portfolio standard of 50% by 2030. This was enacted in 1997, revised in 2019, and really the thought process, the environment has changed so much since 1997 and even 2019. What I mean by that is, I don't think data centers were on anyone's mind, 10 years ago, 20, 30 years ago. So now, how do you address that? You have a solid base load that needs 24/7 power. What do you do there? You really need more fossil fuel based plants. And that contradicts the RPS. So it's a concern. All right. Thank you guys. I think I took more than my 10 minutes though, Bill. I apologize.
No problem.
So having said that, I can go ahead and introduce Enoch. Enoch is with WEC. He's going to build on the large load perspective. So Enoch, take it away.
Yeah, thanks.
Okay, we're having a little bit of a malfunction
Not
there
quite
with the,
progressing.
there we go.
Perfect.
That works.
So yeah, thank you, Sean. I just wanted to, try and frame this up. So I'm going to start big picture. Sorry, I didn't really get to include very much of Canada. There was either this or a worldwide image, but this is the one I went with. So Canada and Mexico kind of get a little bit the shortchanged. But one of the couple of other things I wanted to point out, you can look on the East Coast and you can see right there in Virginia, that's I can't remember what they call it, data center alley or something like that. And it's huge. It's amazing how much has gone there. But then if you look over at the West, we've got dots all over the place. Arizona looks like it's doing pretty good as far as, a bright red dot. So really what I wanted to show with this is it's really going on everywhere. It's wild how much of this, data center demand is growing. And I just wanted to sort of give everybody that big picture because I think a lot of people, I don't know this. Some people may think that this is, sort of, we're special, data centers are coming to us and we're so lucky because we have, this special thing. Based on information like this, it seems like they're shopping around everywhere, trying to get their power from whatever they can. So yeah, I think this really, to me, sort of sets that context that this is big and it's coming and it's here because this is actual capacities. And then jumping into the next slide, this is what we've seen from some of the data collection. We previewed some of this yesterday. This is a different way to look at it, but you can see sort of how we're predicting based on the forecast that we've received at WEC of how these loads are going to grow. And you can see that, 2035, we're expecting another California to be on the Western Interconnection. That's not that far away, and that's a lot. And I think as Sean shared, interconnection queues are huge for both loads and generation, but how much of that's going to come to fruition, right? How much of this are we going to really see when we get to 2035 or 2030? So I this just wanted to show everybody sort of this is the data we are seeing, what we're getting for our information, and this is based on some supplemental information. So if you look at the LTRA that Bill showed earlier, all of this isn't in there because we essentially asked people, can you tell us what you believe is coming, and then what else do you have in your queue? And this shows the full queue. So it doesn't necessarily align with some of the data that we've used for assessments and things. Yeah. One more.
Try aiming it that way.
Frozen up here.
And
Laser works. There we go. So now I wanted to dive in a little bit into some of the things that, I sort of mentioned yesterday. So one of the potential risks that we've talked about is these AI training system pattern things. So this is simulated. This isn't an actual measurement or anything, but this is what some people. The link is there from where this paper was pulled. But this is what it could look like. And this particular one is a 100 megawatt AI load, and it swings 60 megawatts in that slide. It's probably hard to see, but it's swinging about 60 megawatts. If that happens times 10, that's a lot of megawatts swinging. If they, synchronize, find, maybe oscillation mode for the Western Interconnection, or they all start doing something together, it could get, really interesting. And I'll talk about in my next slide, sort of what we've seen as far as consequences of, maybe getting what we asked for. But, I think this is just one of the potential risks. I think Sean covered several others that were very interesting on how we could see this impact us, what we might be able to see, and how we might need to react or be prepared to react. Because if, like I said, if this turns into, say, times 10 data centers training at the same time, all right, now we need to be able to have reactive generators that can swing by 500, 600 megawatts for the next, 2 minutes and then turn off. That's a really interesting problem for us to deal with as an interconnection. And then the last thing that I was going to bring up, so this is kind of speculative. This is facts. So what we've observed for the last several years is an increase in the number of frequency deviations. And what frequency deviations, essentially, we use that as a proxy for load is either increasing or decreasing, or generators are tripping or turning on. And in this instance, since we're seeing the delta increase, and we've assumed that it's primarily due to load. And as you can see, 2022, 2023, 2024, we've seen just a huge growth in the number of swings in our frequency. And what we think is happening, and I guess just to give a little bit more context, this is exactly at midnight, so like midnight to like 12:01 on a daily basis. And we think this is the speculation part. We think this might be due to things like, hey, you've got a time of use rate change, right? So at midnight, your rates go down by half. All right, well, I've set my EV charger or my whatever to turn on right at midnight. Get everybody doing that at the same time. Now we see, based on some of these millihertz changes, things almost as big as a Palo Verde trip sort of situation. So, 1,000 megawatts of load just coming on essentially simultaneously. We've extrapolated this out into the future, and by 2035, we are seeing huge swings that make us nervous. So we're getting exactly what we asked for, right? Like, hey, we want you to change your load patterns. We want you to, maybe use power when it's not the heat of the day, not when everybody needs their air conditioner. So at midnight, we're going to change the rates. And people have done that. And, sort of a consequence of, I think the Internet of Things, some of those other features is now everybody can do it very precisely, and they're all doing it at the exact same time. And we're starting to see sort of the consequence of that approach. I think that's it.
yeah, great explanation. Just a quick comment on that. It's obvious, but frequency is one of those things that is absolutely socialized across the Western Interconnect, right? The frequency here, over the border there in Tijuana, Vancouver, BC, is socialized with the grid dynamics that are being proposed, and some grid dynamics that are starting to actually happen with regard to load, or even a virtual power plant experiment that was known to have occurred in July. it's not point source. You could have a AI training network distributed across 10 data centers, and to some degree across interconnections. Those data center hotspots that you're looking at, those actually, some of those map to really attractive, what we called internet co-location facilities in the late 90s and 2000s. It was all about truing up the internet. And if you could get to a data center and co-locate and connect with the different large networks, even research networks, that was the place to be. And we didn't really think about, at that time, the power consumption was we're going to connect and be there and be able to grow the internet. But now, with these grid dynamics, the things that we socialize and then plan for balancing and for frequency stabilization may very well begin to be impacted by Internet of Things or time of use. And this data, of course, as Enoch mentioned, is still being analyzed. Okay, so we came up with the questions together as a panel we thought would be of interest to the group. We're going to take through those and discuss that, and then we'll have some time for questions and answers from the audience. So first question up is, what is the most significant difference between integrating traditional industrial loads and today's hyperscale data centers? And I think, Sean, one of the things we vetted is that some of the load you're serving really is this new style hyperscale data center. So take us out here.
Yeah, let's go back to our Slido question, right? And I'm not saying you got to go back to it. So one of the things that is different is that typically with industrial loads, you had the opportunity to serve them with distribution. And so it's kind of funny how many different answers we got on that Slido poll. One of the things that not a lot of folks maybe realize is that when you're under the 20 to 25 megawatt mark, you can serve with distribution. So it kind of makes sense that when we look at our OAT process, a small generator is defined right at that range, and a large generator is defined at that higher range, because one's distribution, one's transmission. Not to oversimplify it, but that's one of the big differences here, is that you really have to build out the grid to serve these data centers. There is no quick solution. Now, candidly, I will say that we've been creative at times. We have built distribution as bridging power for some of these hyperscalers. Now, the challenge there is that how do you get rate recovery on something like that? So in those cases, it's been the customer actually paying for that bridging power. And that's not for everyone, right? That's not a cheap and easy solution either, but it gets them in service quicker. So that's where it's really just very different from traditional industrial loads. And the other thing I would mention too is, working with mining customers and other tech manufacturing customers, they're not nearly as quick at building their facilities. Admittedly, the price of gold is pretty high, so that might change. But if I'm building a manufacturing facility, it's normally a 3, 5, 7-year plan to get on the ground. That's not the case with these data centers. They're tilt up, they get their servers, they get their equipment, and they're off to the races. And they're off to the races pretty quickly once they flip the switch. So that's really been the big difference there, is the time to market, if you will.
Enoch, any thoughts from your perspective?
Yeah, I guess just one observation. And I think another big factor is the data centers can kind of go anywhere, right? They need an internet connection. That's about it. And electricity, of course. Whereas, hey, if you're putting a mine in, well, you're going to put all your power right where that mine is located. So you know where it's going to be. So, when we're trying to build our models and predict where these things are going to be using that shoddy forecast information that we don't really know where or how much there's going to be, it's a lot of guesswork. And, when you've got gigawatts of guesswork going into your system models, it's hard to put a lot of trust and faith in the answers you're getting. So we end up doing a lot of scenario analysis. So I guess, that's just a small addition.
Yep. The only thing I would add, so I'm going to put my hat on from long ago when I was an internet service provider and had 155,000 customers. That number, what was our packet load? That was hard to estimate because it was all spread over school districts across Western Oregon. But the other difference between those industrial loads is data centers, almost all of them are going to require high-speed telecommunications infrastructure. A lot of us utilities, I was a utility practitioner, we did that. We leased fiber. When I left the industry, you could easily stack 40 different colors of wavelengths on one fiber, and then that jumped to 80. So the growth in telecommunications capacity versus the amount of electrons it required to power it has been exponential. But where some of those data centers are, I know that those are hotspots for telecommunications infrastructure, and utilities have done that. And I think some of the projects I know about, I know that, oh yeah, here's a transmission operator. They've got 72 fibers that they put in. I know that because we collaborated on telecom customer projects 25 years ago. Okay, we're stuck here. Okay, next question. Small to medium entities, how can they prepare for the interconnection process, and what information is critical for the utility to receive early on? Sean?
Yeah, absolutely. So we didn't get too much of a chance to talk about this, but I would say the early engagement, getting the load data in the site info. So to Enek's point, right? Some of these data centers are looking at existing buildings. So you can certainly see when 1 million homes gets built, but in the same sense, if it's just a commercial industrial area in warehousing is being repurposed, that's probably not the best fit. But maybe there's an opportunity there. So it's really about that early engagement. The other piece that I would throw in here, and this is kind of related back to our IRP, one thing we've done that has been vastly different than what we did in the past is our transmission planning really never stops. And what I mean by that is we have area plans that are part of that 10-year planning process. And so historically, it was one of those things where every 3 years you would take a look at it. What do we need to serve and support the IRP? What do we need to put in the IRP? What do we need to make our regulators aware of? What's changed is our area plans are something we look at on a monthly, quarterly basis, and it's a very robust approach. So rather than, okay, we're going to build, a transmission line in a substation, right? So something that maybe you would have seen 10, 15 years ago. It's a plan that's phased. You have phase 1, 2, 3, 4, 5, and to simplify it, let's build out a 100 kV loop, a 200 kV loop, a 300 kV loop, a 500 kV loop. What are the trigger points to where we need to start really considering this phase a real thing? That is vastly different than what we were doing even 5 years ago. So it was a plan that we looked at every 3 years, and now it is something that we're always watching for when we need to really start. And folks, if you think about it, it makes sense because these material and logistics challenges, they're not going away. I hate to break it to you. Yeah, that transformer may take 4 years to get there, but I was sharing with Bill and Enek, we had a very large transformer that was delivered to us that it actually didn't fit on the rail, and it struck the side of a mountain in rural Nevada. How do you plan for things like that? The data center doesn't want to hear that, but in the same sense, no one could have planned for a transformer hitting the side of a mountain. Those things they're not top of mind. You really got to plan for the worst.
Yeah, I guess just to jump on that, this question, we've already shared a bunch of links to ongoing activities. I guess that for the smaller entities, I would encourage you, like, you're probably not going to have robust, really well-defined interconnection processes necessarily. But if you're paying attention and you sort of glean best practices from all these ongoing efforts, the e-sig, the NERC task force. I think there'll be a lot of opportunities for you to embrace some of the things that come out of those. And I think the other thing that really could generate is a lot of consistency, so that, you know, the Googles of the world are going to this area, trying to get interconnected. They're hearing the same information, getting the same data requests that they do from this other area that they're also going to try and interconnect with. And I think that will help everybody. I think it'll create a lot more opportunities for us to make sure we're getting the information we want and need, and we can account for it correctly.
Yeah, what Sean's referring to, I think right about the time of the, I think the Eastern Interconnection event, you know, I know I was providing to management some public reports with some of our stakeholders in the Western Interconnect that were talking about their load. They, you know, really good planning, had planning in-house, but their load was where the original planning cycles thought it would be in 2027. So at the top of this deck, we had planning, and it's almost, in some of these, especially with Sean's experience, it's a planning loop versus a planning cycle. Next question on infrastructure. What are the most common unique transmission requirements or challenges we've encountered, should say Sean's encountered, and what steps you're taking to address them?
The norm has changed. I don't think I am unique in mentioning this. Is it sure feels like not a day goes by that we don't get some bad news on lead time. So really just understanding that transmission is a different animal. This isn't something that you just go out to a vendor and you acquire it and you're able to pull those poles, the wire, the hardware, the conductor, whatever, right? It just feels like the industry itself is going through those struggles, and I don't think we're alone. And when you look at Enix's his map of the U.S., you see all those hot pockets, right, of growth. We're all competing for the same thing. So that is really one of those unique things that our customers in particular, they don't always understand. So for example, you go to a tech company, you say the lead time is 3 years for a transformer. 6 months goes by and the lead time is 4 years for a transformer. They don't want to hear that. And so you really have to understand that we're in changing times. You have to get more creative with things. Some of the things that we've really looked at, for example, is better spare programs. So maybe we ramp up our spare programs. Bringing things into inventory. So typically we would have material, non-stock and stock material. We've changed our perspective a little bit on that non-stock and stock material, because you can't wait 3-4 years for some of this stuff. And as you're adding more to your grid, you also want to have spares for that infrastructure. That's the other piece of this that we've really had to think through, which is definitely unique to transmission, and I would say, you know, substations as well.
Anything to add, Enoch?
Nope, nothing for me.
Last question is on reliability and resilience. And from a WEC perspective, how are loads, how are these loads affecting the broader grid, and measures are being implemented to ensure regional reliability?
Yeah, I'll kick this one off. So we've obviously started doing a lot more data collection. I don't know how many balancing authorities are in the room, but we added several questions about large loads to our loads and resources data requests last year. I already mentioned the NERC alert. We're expecting and planning to use a lot of information from that, and again, would really encourage everybody to make sure that they're paying attention to that, getting it in on time, trying to fill it out as robustly as you possibly can. So data gathering is a big thing. We're also exploring what else do we need, and I think that's going to evolve over time. We'll just learn more and more about the right questions, the right time to ask them. Another thing that we've started doing is, and it sort of gets to the previous question about physical infrastructure, but we've been adding, transmission constraints to some of the products we develop. So in the regions, we do a thermal assessment. That's a NERC document. All the various regions of the North America contribute to it, and there's a WEC section. And in that, for this year, well, starting next year, you'll start to see in the 2026 LTRA, you'll see a consideration for transmission and how much transfer capability we have. We're seeing loads go up. We're not seeing a whole lot of new transmission get developed simultaneously, right? Because of the timing differences that we've already talked about at length. So we're trying to monitor that and see how big of a risk it introduces, if we see delays in transmission projects or things like that. But yeah, I guess going back to it, it's really coming to, from my perspective, for what I'm trying to do to look at this risk. It's really data, and we're just trying to figure out what to ask for, when to ask for it, and how much we can rely on it. As I mentioned before, forecasts, and I think Sean mentioned as well, like, okay, we've got a huge interconnection queue. How much of that is real? And right now, everybody's sort of taking a guess, and it'll be interesting to see how that progresses.
Yeah, great points, Enoch. The one comment I had on physical infrastructure is that, it would, with small to medium entities, many of those are not going to have the transmission capability in-house if a large load comes. The planning may or may not be coming from who's going to be building the transmission and operating it. So certainly those can be some constraints. And the other constraint too is that you have a large load. Where's the energy coming from? If you're locating a large load in Oregon or Washington, the decarbonization initiatives are going to program some aspect of what that energy looks like if there is extra energy. I mean, my state, we're standing down a large coal plant at the end of December. There's possibly some new inertial generation coming online in Canada that we just learned about, but it's not going to come. The retirements and the rebuilds and reprovisioning are not happening as fast as a tilt slab data center that could be stood up in 18 months and demand 400 megawatts of load. So with that, we have some time for some audience questions and online ones if we don't have any from the audience here.
I do have an online question for you.
Sure.
With the continuing growth of large loads and their grid and system impact, is there any effort out there to regulate their interconnections, for example, the OATT, or will each entity be responsible to develop its own interconnection process?
I guess I can kick that up. So far, it has been everybody's doing their own interconnection process. I know we've had some discussions in the WEC technical committee environment about developing a guideline or something. NERC's having the same discussions about a guideline. And I don't want to despair too much, but guidelines are optional, voluntary, and there's mixed results from using guidelines. Some people adopt them, and that's awesome, and it can be very effective, and some people don't. So I think in this large load environment, like we've talked about, like there's an economic motivation to see if you can get them interconnected to you, and if you can make it easier than somebody else. We don't want it to be a race to the bottom. So I think I answered the question, but if not, yeah, thank you.
And certainly over in the large loads track, there's some presentation there by Southwest Power Pool. We didn't really want to introduce their resource request 696, which is really stakeholder-based and market-based here. That certainly is one approach. Like as Enoch mentioned, it's voluntary and it's market-driven, but the conversation continues, obviously, with the large load task force, and all the activities going on there is collecting the data to figure out what the right size is. And in the interim, it's generation and interconnection agreements and working with the planner and the transmission entity, as Sean alluded to. Sean, do you have anything to add to that question?
I think it's a challenge, right? That's, I was going to mention this. One thing that we've seen that's been very unique over my career in the industry is we're seeing more inquiries about fringe accounts. What I mean by that is, and this is probably germane to the small to medium operators, is we have customers that just, they don't understand or they don't necessarily want to understand service territories. And so we see some of this too with other co-ops, with other utility providers, where there's not always a lot of clarity on okay, if I'm a customer here, am I your customer or am I their customer? And so I bring that up because when you start taking on, standardization in the interconnection world, that is a lot of entities impacted, and how do you get consistency there? It's going to take a lot of effort to make that happen, and some utilities may not be willing to make that happen. It's difficult enough to kind of figure out if you're on a state border who's that customer is, right? Let alone interconnection consistency.
Thank
Hope
you,
I answered
Sean.
that, Enoch. Bill.
Yeah. Do we have any other online questions,
We
Mealy?
have one in the room.
Okay, very good.
So I'm going to set up the foundation for my question, right? The first 1 gigawatt hard drive was 500 pounds. And now we don't think about the size or the weight. So as small, medium, or for that matter, large entities start the process and setting up the infrastructure for this large loads, at the same time, the NVIDIAs, the AMDs are developing chips to reduce the energy consumption. So we say it takes 3 years for us to set up this substation, support a data center. And 5 years from now, the data center says, I'm done with the contract. Here's your check. I'm cutting it off. So what should we be doing to account for this possible lack of no load?
Yeah, that's a great question, right? One of the, and I don't know that we have the answer, but probably from the standpoint of planning and forecasting, going back to the presentation a couple of large load task forces ago, is that coordination is really, this is load where it seems reasonable that entities are going to need to have, the load serving entities or the utilities are going to have some understanding on what the planning horizon looks like for that load, which maybe that's a lot different than when an aluminum plant's built and you say, well, we got phase one, then we're going to have phase two and phase three. I very quickly, just an experience when I was a practitioner, we recruited and sourced a chip manufacturer in my home city. That was a huge deal. That particular manufacturer told us they're looking at a 40-year horizon. We sourced a unit substation for them, 115 kV radial. This was before the regulations, before NERC regulations. And really, the whole community, we took that planning and took that long view, and then they closed down. Like, I don't remember the exact number of years later, but it was a bit of a surprise, and I don't have a good answer for that because of the dynamic nature of data centers, chipsets, how fast they can go. And I think the best thing to do is try to look at this, that you can't do a one and done for planning for even 6 or 12 or 18 months, as Sean was talking about. They're doing it more continuously. And I think that brings us to the end of our hour.
Thank you. We have a half-hour break, so be back in this room at 11 a.m. Thank you.